Hi guys, today we're going to learn how to graph parametric equations and eliminate the parameter. Now, let's recall what you have learned in Algebra 2 and below. You have studied a lot y equals f of x, right? Now, today what we're going to do is we are going to find another way of representing curves in a plane, and it's called parametric equations, okay? So when we have parametric equations, we're going to let x to be f of t, and yes, it's t, and y equals g of t, where f and g are two functions whose common domain, please note that the domain is common, is some interval I. The collection of points defined by the point xy is going to be equal to f of t comma g of t, and this is called a plane curve. Sometimes the parametric equations, and the need of parametric equations comes because they don't need to be functions, they don't need to pass the vertical line test, okay? So the equations x equals f of t and y equals g of t, where t is in the interval, are called parametric equations of the curve. The variable t, okay, this is very important, is what we're going to study, is called the parameter, okay? When we're sketching a curve by hand, represented by parametric equations, we're going to use increasing values of t. Therefore, the curve will be traced over a specific direction, okay? This is going to give you the direction that we're also going to learn today. This is called the orientation of the curve, and we're going to use arrows to show the orientation or the direction, okay? It's going to be pretty simple. Just pay attention to the details and you'll be fine. Many times when parametric equations are given, we wish only to sketch the general shape of the plane curve. In that case, what we want to do is to eliminate the parameter. And that's also something that we're going to learn today. To create a rectangular equation in the form y equals f of x, that those are your best friends from middle school up to Algebra 2. The technique to accomplish this is to solve for the parameter in one of the parametric equations, either x or y. You are usually going to choose the easiest to do so, and then you are going to replace the result in the other equation. You're going to see that this is pretty straightforward. It's very user-friendly, okay? For this example, what you see is that x is equal to t squared minus 3, y is equal to 2t, and t is restricted between -2 and 3. Okay, so they are telling you the restriction of your t's here. So what are you going to do? As the example before, you are going to create your table. This one, I'm just going to put more numbers because they are giving you more specifics here, and both equations are friendly. It's up to you. I would put at least 3. Okay, so you have t, x, and y. Okay, so what are you going to do here? Well, you can plug -2. Okay, so when you plug -2 here, you have that that's going to be 4 minus 3. That's a 1. Okay, then you plug the -2 here, giving you, what's that? -4. Okay, so you go and sketch your point 1, -4. So 1, -4 is going to be 2, 3, 4. Okay, over here. Okay, so that's where we start. Then the next point that we have, you can do -1. -1 squared is 1 minus 3. That's going to be -2. Then you put the -1 there, so it's going to be -2. So the next point that you have is -2, -2, which is over here. Okay. Then you have 0. 0 squared minus 3, that's -3. 0 here, so you have that it's going to be -3, 0, which is here. So you can see that your graph, the direction that you are having is something like this, so it's going this way. Do you see it so far? You keep sketching 1, what we have, 2, 3, well, let's do all. So you have that 1 minus 3, that's -2, 1 times 2, so you have that one is going to be, what's going to be that? -2, and that's going to be +2, so you can see here. Okay, that's your next point. Then you have 2 squared 4 minus 3, that's going to be 1. 2 times 2, that's 4, so your next point is going to be 1, 4, so you have it here. And last but not least, you have that 3 squared is 9 minus 3, that's going to be 6. And then you have that 3 times 2 is 6, so you have your point. Okay, 1, 2, 3, 4, 5, 6. Okay, did I count correctly? Yeah, 6. Okay, so 2, 2, 2 over here. So look at that. Okay, it looks again like a parabolic situation opening to the right. Okay, and this one is shaded. Okay, there's a beginning and an end from the restrictions that you have over here. Okay, isn't that beautiful? So we have our sketch and our graph. Now, what's the business here? You're going to tell me, well, this one looks easier. Yes, indeed. Okay, so let's solve the t for that one. You have that t is going to be equal to y divided by 2, right? Okay, so now what are you going to do here? You plug this one into this guy. So what do you have? You have that x is going to be equal to what? Y divided by 2 squared minus 3. In other words, you have that it's going to be y squared divided by 4 minus 3. Therefore, what do you have here? Thus, my equation, my rectangular equation, is going to be this one. Okay? Now, what are the restrictions that you have for the y? Okay, so what are the restrictions for the y? Well, look at the y's from -4 to 6. Okay, so and those are the restrictions that we have. Isn't that nice? So for this last example, we have that x is equal to 3 plus 2 cosine t and y equals -1 plus 3 sine t. So you're going to tell me, what are we going to do? They are not giving us restrictions. Well, you know, kind of like the idea behind sine and cosine. We're going to use a unit circle. Okay, so as before, we're going to create our table. Okay, so your table with t, x, and y. Okay, nothing new here. Okay, so you create your table. Okay, so you have t, x, y, and what values are we going to put? Well, I would put the most significant for the unit circle: 0, pi over 2, pi, 3 pi over 2, and 2 pi. If needed, you can put more, but you might not need to. Okay, so when you plug 0, what's cosine of 0? That's 1. 1 times 2 is 2, plus 3, that's 5. And then you plug the 0 here, so you know that this goes to 0 because sine of 0 is 0. So that's -1. So we start at the point 1, 2, 3, 4, 5, and -1. So that's my first point. My second point is going to be 3 plus 0 because cosine of pi over 2 is 0. So that's going to be a 3. Then you plug the pi over 2 here, having a 1, so that's a 3. 3 minus 1, that's a 2, so 3, 2, 1, 2, 3, 2, so you are going this way. Okay, so you are going from here to here. If you need to know why it's circular, you can plug more values in between. Okay, but this is kind of like a smooth curve there. Okay, then you plug the pi there. You know that that one is -1, so that's going to be a -2. 3 minus 2, that's 1. Then this one is going to be 0, so that's going to be -1. So you're at the point 1, -1, which is here. So this is going to be your situation. Okay, if you need more points, because you just need to, you can put more points. I don't need to because I kind of like know the shape. It's going to be a circular shape here. Okay, so then we plug 3 pi over 2. Okay, so you have that 3 pi over 2 here. What's going to give you the 3 pi over 2? 0, so that's going to be a 3. The 3 pi over 2 here, it's going to be negative, so that's going to be -4. Okay, so you are at the point 1, 2, 3, -4, so that's 2, 3, 4. Okay, so you can see that this is so far the shape that we have. Okay, well, here I was very shaky. Okay, doing that, so let me just do it straight. There you go. Okay, and then last but not least, you have that it's 2 pi. You know that that one is going to be 5, -1, so you close here your elliptical situation. It's not only circular, it's elliptical situation, so that's what we have. So we have the graph, we have the direction, and we have the table. Great. Now, how in the world we're going to eliminate the parameter? Are we going to use arc trig? Please don't. Okay, you know that it has a lot of restrictions, the arc trig. So I would do t, that it's between 0 and 2 pi here, so you can be happy. Okay. Now, the next situation that you have here, okay, is how to eliminate the parameter. You need to remember one of your best friends from the unit circle. Your best friend from the unit circle is always cosine square of theta plus sine square of theta is equal to 1. You know this, and this identity is going to be very important also for parametric equations. So what we're going to do here to avoid using the arc trig or the inverse trig is you are going to solve for both the cosine and the sine part of the function. Okay, so for the first part, I'm going to do them separately. Okay, so I have x equals 3 plus 2 cos t. So I want to solve for cos t. So what you're going to do is you are going to pass the 3 to the other side, making it negative, so you have a situation like this. After that, you are going to divide both sides by 2. So what do you have? You have x minus 3 divided by 2 is equal to cosine t. Okay, so you are very happy here because my cosine of t is alone. Now on the other equation, okay, y equals comma, right? Y equals negative 1 plus 3 sine t. Okay, what are you going to do? You are going to solve for sine of t. So we're going to pass this negative 1 positive to the other side, so we have y plus 1 is equal to 3 sine t. Similarly to the previous equation, what we're going to do here is we're going to pass the 3 dividing both sides, so you have y plus 1 divided by 3 is equal to sine of t. Now I'm very happy because my sine of t is alone. Now what are we going to do? Well, we have this equation. We need to use it, okay? Use your trig identities, okay? So you know that it's going to be cosine. What's cosine? Okay, cosine is x minus 3 divided by 2 and all of this square plus your sine, which is y plus 1 divided by 3 square, and that's going to be equal to 1, okay, from this trigonometric identity. Okay, so you have a situation like this. In addition to that, you can make it even nicer, okay? How? You have that your rectangular equation is going to be x minus 3 squared divided by 4 plus y plus 1 squared divided by 9, and you can see that this is an ellipse, okay, that it's obviously you can see that here, well, it's not obvious, but now it is 3, okay, so you can see that 3 is the pseudo radius that we have here, and the 2 is the pseudo radius representing the x-axis over here, so you can see 3 and 2. Isn't that beautiful? So you can see that this equation, okay, is an ellipse, okay? So this is something that you can use with the trig equations, okay? You can use all the trig identities that you know from before, okay, to use and form a beautiful rectangular equation. In this situation, we have a conic section, which is an ellipse, okay? So if you have any questions, write them on the comments, and I hope that you find this video helpful. Bye!